everyone. Thanks for having me here. I'm Yunyu Shu from Brown University. So today it's a great honor to be here to present the joint work with Jiayue Zhang on the topic informed climate adaptation. So the brief motivation is in recent years, with increasing climate risks, many countries are facing increasing challenges of both protecting environment and reducing poverty. So most of the, as shown in this map, most of the regions that with heightened vulnerability to climate risks are predominantly located in sub-Saharan African countries. So around 1/3 about world's drought happened here, which has led to magnified income shocks, especially for those who rely much on rain-fed irrigation. And so it's likely climate change could push more people back to poverty. So this leads to the heated discussion over two main strands of agro-environmental policies that could essentially better incentivize adaptation. So the first popular option we think about is the input subsidies that directly target pro-environmental behaviors by offering conditional cash transfers. So a good example you can think about is a standard payment for ecosystem services. I pay you subsidies to increase tree planting or stop crop burning. On the other side is more market-based solutions, which is the output subsidy that pay a higher price premium for those greener products after adopting certification. So if we go to the grocery store nowadays, we may find those coffee brands or chocolate brands with some fair trade or rainforest alliance labels. They are often charged at a higher price. So one natural question would be, which one is performing better in incentivized adaptation? So theoretically, the answer is ambiguous because it really depends on individual beliefs. So by individual beliefs now, we not only mean by your beliefs about climate risk, but also beliefs about how you think of this adaptation tool could reshape your production function. And on the other side, different policy options may rely differently on character beliefs. So in this sense, the information nudging that aim to shifting beliefs could drive differential behavior responses. So this comes to the motivation of the research question, which is how does information shape climate adaptation under different subsidy schemes? So to answer this question, we are focusing about the cocoa farmers in Ghana to study their climate adaptation decision, which is where the shade grown practice is strongly recommended as a green adaptation tool to against the climate risk. So as we can see here, by meaning is like a shade grown practice is essentially planting forest trees scattered around the cocoa farms to provide shade for cocoa plants. So as you can see here, these are typically really tall timber trees. So by contrast, for these cocoa trees, they are much shorter. So as you can see here, I'm squatting under the cocoa trees while looking at the sky, looking into those towering shade trees. So specifically in this paper, we are trying to conduct a lab in the field experiment to compare farmers' responses about shade tree planting under two subsidies. So one is an input subsidy, which is direct cash payment, depend on the number of shade trees people planted. And the other is the output subsidy in our context, which is we offer a higher price premium for those for cocoa beans produced from more shaded farms. So in this sense, once you decide on the number of shade trees planted on your farm, what can be pinned down is only the price premium attached to this shade. So in this sense, the total subsidy income you can get not only depend on the price premium, but also depend on the how much harvest are you gonna, how many cocoa beans are you gonna harvest from these more shaded farms. So from now on through the whole presentation, I'm using the color for the trees for the input subsidy, and for the color of chocolate is brown for the output subsidies. So to better incorporate how the individual belief play a role here, we interact these two subsidy treatment with an information nudging, which we provide information for both climate risk in our context is the irregular rainfall patterns, as well as the shade benefits. So to further incorporate the results, we use a model to explain why certain belief updating due to information nudging could drive differential behavior responses. And essentially, we are trying to incorporate their beliefs about both the rainfall as well as the shade benefit into each farmer's production function. So lastly, we try to link the lab results to our real-life results by validating the lab treatment effects via their real-life treatment requests under the part of the Green Ghana program. So it's essentially reforestation programs that incentivize and encourage most of the Ghanaian people to plant forest trees. Okay. So to preview of the findings, the first we find is without information, input subsidy performs better in terms of increasing more shade tree planting. However, the role of information is more pronounced when combined with output subsidy. And we find the consistent pattern when we look into the number of tree seedlings under the Green Ghana program for both the initial request as well as the actual pickup they did like 3 months later after the lab. So our model provides a more intuitive explanation, which is under the output subsidy, the role of information is complementary to the subsidy increase, while under the input subsidy, the role of information is constant but positive. So mapping into the mechanism, we do see the information nudging shift people's beliefs, but only about people's belief regarding the shade benefits in terms of they are more confident about the shade benefits, as well they are more agreed, as well resulting in a higher perceived level of optimal shade. And I will come to the detail about how we measure this later. So the next is we don't find any evidence regarding people's belief about the rainfall risk because we don't see any belief updating about rainfall level or rainfall variability. So lastly, as the cross-check, we're trying to see the previous underperformance of output subsidy is actually due to the subgroup of farmers who are less confident about the shade benefits, as well as they are more pessimistic about the rainfall pattern in the future. So before we move on to detail, let me give you more background. Why cocoa in Ghana? So not only because we choose the cocoa industry, not only because it's super vulnerable to climate risks. So as we can see here is in the last harvest season, so due to climate change, the whole global cocoa bean market has experienced a more than 10% global bean decline. And this has led to a 5-fold increase in the global cocoa bean price. More importantly, this is the most important cash crop in Ghana that's supporting more than 20% of the local population. So as a solution, the shade management is strongly recommended as a solution for both the function for shifting the productivity as well as providing tremendous environmental benefits through the carbon sequestration. So how does the current practice in Ghana looks like? So give you more background is in Ghana, the whole cocoa industry, because it's really important. So it's under the whole control of Ghana Cocoa Board. So it's the main government sector that taking charge of the whole industry. So before each of the production season, the Cocoa Board has the option. They can set up the price for all the. They can set up the uniform price for the whole cocoa market in Ghana. And also, they recently just raised the recommended shade level to 16 trees per acre. But how does the real shade adoption look like? So based on our baseline characteristic, what we find the average is only around 9 trees per acre, which is really under-adopted according to their recommended level, but with really large variation.
And sorry, what is this recommended level? Is
16 trees per acre.
Okay, so this is sort of ideal setting we would like to such that the economy will be adapted to the future changes in the climate. Is that the right reading?
Yes, yeah. But this is a really like complicated question. So for the scientifically, the optimal level really depends on like your soil type as well as your land information. But on average, I think it's like under adoption according to the scientific average level, which is 16.
Is that because the cocoa trees grow better with shade trees? Is that? That's where the 16 number comes from.
So the 16 number comes from the scientific literature. Is if you think about like the shade trees, it's just planted, scattered around the cocoa farms. And so if the level is too high, and then must cause some like congestion costs. But if it's too low, then probably like not enough shade. So
the cocoa tree was damaged by too much sun. They want
yes, especially when the rising like extreme heat as well as less rainfall. So providing shade can provide more of the protect against the strong sunshine and also retain like groundwater.
but it's nothing to do with carbon, right? Shade.
Yes. So for today's presentation, I think it's more focusing about the private benefit. But I think for the public benefit about the carbon is why we need to provide like subsidies to support the shade grown practice in African countries.
Presumably, they could also potentially be paid for somebody who wanted to have carbon sequestered.
That absolutely. And also this is related to like how we can kind of like the channel for the cocoa port perspective, how they can channel funds from the international market to Ghana. That's where this comes from. So let me give you the overview about the interventions. As already mentioned a little bit, we are like the whole intervention is centered around how to better incentivize the shade grown practice. And we are considered two subsidy groups for the input and output, as well as the information nudging. So I think it's more clear. Let me show you on more detail how we design the subsidy program and in the way we introduce this to our farmers in the lab. So for both the input and output subsidies, we consider 4 different levels of shade, varying from not qualified to high shade. And what's different I want to mention here is under the input subsidy, once you determine on the number of shade trees, then the lump sum of payment you can get is already fixed. However, under the output subsidy, once you determined, then what already determined is just like how much is the extra amount as the price premium you can get per bag. So this subsidy level is really carefully designed for the people who have the average yield. They can get the nearly equivalent amount of subsidy under both the input and output subsidy. So give you a sense for based on our sample farmers, their average production is about 2 bags per acre. So if you calculate comparing to the 800 tokens as a standard producer price, then if you choose the high level shade, then the price premiums is essentially equal to 12% per acre. Okay. For the information nudging, it's worth noting, we don't provide any quantitative evidence. We're just showing this in terms of like for the irregular rainfalls to talk about the climate change risk. And for the shade benefits, we're just using this graphical to illustrate to our farmers how shade trees can protect the cocoa trees against the hot sunshine, as well as how to help them to restore groundwater, as well as better for the biodiversity. Yeah. So before jumping to the results, let me brief a little bit about how our lab session take place. So in the lab session day, all our farmers belong to the same treatment arm. They are invited to come to the lab session together, and they're invited to make their independent decisions using their own knowledge, learning from their real farming practice. So in the game introduction, each farmer are making it clear about they need to make 2 individual decisions for 2 1-acre standardized cocoa plots with some fixed number of starting tokens, and they need to make the decision about number of shade trees and facing different pre-specified plot information and some other non-tree plots. So this essentially is trying to incentivize the farmers to using their own knowledge from their real farming to do this, play this game. So farmers are well incentivized in the sense the game earnings they can get is depend on the realized game based on they realize the game, they can from one of the randomized selected game outcome. So each game outcome will depend on their subsidy income they can get, and also some tree cost. Also, some of the standard price of the sales, which determined by a pre-trained machine learning production function that we measured and input into the game function using their real farm information, including the rainfall risk and other weather shocks. So by the end of the game, we asked them to enter into the lab access survey to get their information about number of tree seedlings requested in the Green Ghana program. So regarding the data collection, we are trying to collect about, we got a total sample about 1,900 farmers from 13 random selected communities in 2 regions. And we did the data collection separately, one in 2023, the other in 2024, right after the main harvest season. So worth mentioning is our sampling is coming from the cocoa monitoring system, so that makes sense. Our sample is representative for the smallholder cocoa farmers in Ghana. Okay, so let me jump to the results. So as you expected, the first main outcome of interest is number of forest trees people choose to plant it. So as we can see here is comparing the input subsidy and output subsidy only. Both subsidies increase the number of shade tree planting by more than 70%. But the output subsidy is underperformed by around 10%. And worth noting here is for the control mean, it's around 10 trees per acre, which is really similar to what we find in their real farms. And what's more interesting is when we add in information, which is shown in this darker color, what we find is information has positive impact under both input and output subsidy. But the rule of information, the magnitude is much larger under the output subsidy and close the previous gap. So we may still wondering, okay, this is just a lab results, how this can tell us anything about the reality. So we try our best to push some effort towards this angle, which we looks into people's decision about their initial tree request about the Green Ghana program right after the game in the lab access survey. Also, 3 months later, we're trying to do a phone survey as well as the actual tree distribution to see how our lab intervention affect the number of forest tree seedlings. So what I plot here is because essentially this Green Ghana program is only one subsidy we can validate. So I pour the 2 subsidy only groups together as the subsidy only, and the 2 subsidy groups with information as our subsidy information. So what we find is varying from the lab access survey to our tree distribution 3 months later, we find a robust positive impact of information. Okay. So what drives this? What's the mechanism? So what's the role of information driving a positive impact of information in increasing shade adoption? So for the interest of time, I'm just using a toy model to show some intuition behind how we can incorporate about the 2 dimension of beliefs into farmers' private production function, and also jump directly to the empirical results. Okay, so for the production function, it's quite simple. Y is production function which determine on the key input, which is number of shade trees. So what I want to highlight is how we can use 2 parts to incorporate farmers' beliefs about the shade tree benefit. The one is our theta, which is a constant positive returns in yield per tree that irrelevant to the rainfall risk. And the second is comes to our loss function, which is trying to capture the interactive effects of rainfall and trees. So R is the stochastic rainfall, and here it has 2 mentions. The first is a higher rainfall actually means a lower loss. And the second is the sensitivity of our shade benefit is larger when you're facing a lower rainfall. Okay. So then it's about our subsidies. So for the model perspective, we're trying to make it from the categorical to our continuous measure. So let me give you the intuition behind this output subsidy, because the input subsidy is quite intuition. So under the output subsidy, this tau T is is trying to capture your price premium. So tau will be a really small number. So think about this is if you plant your shade trees scattered around your cocoa farms, then the number of shade trees you planted is a good proxy for the proportion of cocoa beans called shade grown cocoa. So this subsidy premium is only paid for those cocoa beans under shade. Okay. So then we are trying to do some ex-ante optimal decision about number of shade trees, and let's look at the marginal benefit of per tree so that hopefully can give us some intuition, which is under the input subsidy, the marginal benefit per tree is constant and positive when you increasing the subsidy level. And on the output subsidy, you have a mitigator, which is your expectation about the yield. So that's why it's possible under the output subsidy, you have a complementary impact. Yeah.
You're setting your note, don't have this idea that eventually the price per unit eventually has the premium of quality, like something you discussed in the beginning, right? The price here is the same regardless of whether you have more or less shade trees, right? The price for the farm.
Yes, for input, but output, we are inducing this as a price premium. So this part, the PY is the standard price, and tau T is the price premium, and the price premiums is increasing in shade level. Thanks.
Sorry.
I just talk about this too quickly. Thanks for clarification. Yeah, great. So then looking into the empirical results, which part of the beliefs are shifted actually by our information nudging? What we find is people do have a positive upward updating about the shade benefits, but we don't see any evidence about the climate risk. And as a cross-check, we do ask directly about how farmers perceive their production function with regard to the shade level. So how we do this, essentially, rather than asking there directly about what's your optimal number of shade trees, for each farmer, we are trying to ask about your expectation about the cocoa yield when varying the shade level. So each farmer, we can get all these two sets of dots. So the blue for the normal weather and the orange for the harsh weather. So based on those two sets of plots, we can try to infer what's their perceived optimal shade level in their production function in their mind that maximize their expected production function. So based on this measure, we do see the information nudging actually makes the people to upward shift their perceived optimal shade level. So given we still have some time, let me give you the last results, which is how we can try to have some result regarding the extensive margin. So we are trying to, in the lab access survey, we try to measure how do you think about, what's your willing to pay for such a program if this comes true? What do we find is like the output subsidy has a lower demand. So this potentially related to the risk component within the output subsidy. But what we do find is given conditional on people who are interested, the information increase the likelihood that people will send a message back for more information regarding our subsidy program. So I think that's pretty much for today's presentation. So if one takeaway from this presentation is information matters, and output subsidy has greater potential in driving adaptation than input, but only when the beliefs are reasonably correct. Thanks.